So that pattern you hopefully noticed in your warm-up was what is called difference of squares if we look at it backwards. So say that you have x squared minus 25. X squared is a perfect square, you're squaring x, and 25 is 5 squared. So if you have two perfect squares like that, it's always going to factor into two binomials that are the same but have opposite signs. And they're basically like the square roots of x squared and the square root of 25. So just x plus 5 and x minus 5, because that means you have your middle terms of positive 5x and negative 5x subtract off to 0, and you just have x squared minus 25 when you multiply it together. If I look at this one with two terms, they share a common factor. So as always, you want to factor out your common factor first, and then you have another set of perfect squares that are being subtracted. So if you think about what you square to get 9, you square 3 to get 9. So this should factor into one factor of x plus 3 and one factor of x minus 3. Because if you multiply it back together, that gives you your x squared plus 3x and minus 3x. And then negative 3 times positive 3 would be negative 9. Let's look at another one that isn't just 1x squared. So if you have 16x squared minus 81, you can think of what do I square to get 16x squared? Well, that would be 4x times 4x. What do I square to get 81? That would be 9. You can also think about taking the square root of 81 and getting 9, or taking the square root of 16x squared and getting 4x, if you want to think about it that way. And then you'll have one binomial that has a plus and one that has a minus. You could always factor using guess and check, or find the two numbers that multiply to 16 times negative 81 and add up to 0, because there's a 0x in the middle. But this is kind of a shortcut that's faster. So let's combine today with yesterday and solve some equations. So we have 0 on one side of our equation. So let's factor and set each factor equal to 0. To get x squared, I'll have to have x and x. What do I square to get 49? 7. Since there's 0x in the middle, I need a positive and a negative 7. And then if you set each factor equal to 0 and solve, you'll have two solutions, either x equals negative 7 or x equals positive 7. And you can always check your equation solving if you plug those back into the original. 7 squared minus 49 does get you 0, and negative 7 does as well. Let's subtract 75 on this one to get our 0 on one side of our equation first. And then we could factor out a common factor of 3, which will leave you with x squared minus 25. If you don't do that, then you're not going to be able to see that you can factor this using difference of squares, because 3 is not a perfect square. But this one you can factor into x minus 5 and x plus 5. Now, if you have that factor of 3 out in front, sometimes this throws people a little bit there. When you go to set your factors equal to 0, remember that there is no way for 3 itself to be equal to 0. It's just 3. So that doesn't give you any solutions to your equation. But your factors of x minus 5 and x plus 5 could be equal to 0 if x is positive 5 or negative 5. So those are your two solutions to your equation. So cubes can also be factored using a special pattern. They factor into a binomial times a trinomial. So say you have something like x cubed plus 8. I wrote it under difference of cubes even though it's a sum, but they work similarly for the pattern. You think about kind of like when you did squares, it's what do you cube to get 8 and what do you cube to get x. So you can always take the cube root of 8, or if it's a big number, of whatever number in your calculator. And then if you look at how the pattern works, it looks a little intimidating, but once you do a couple, it's really not too bad. So I always kind of give myself some blanks here to fill in. And then in your binomial, you're taking whatever values you have being raised to the third power, so just x and 2 go in there. I'll fill in my signs at the end. And then in your trinomial, your first term is the first term in your binomial squared, so square your x. And then your last term is 2 squared. And then I'm going to come back and do the middle term. The middle term is just what you get when you multiply those two values together. So 2 times x just gives me a 2x for my middle term. Now the signs are the same sign that you had to start with. So it was a plus, so my first sign is going to be a plus. My next sign is going to be the opposite, so it'd be a minus. And my last sign is always a plus. You can remember the signs using like an acronym if you like those. You can think SOAP. So S for same sign, O for opposite, and AP together for always plus is how I remember it. If you think about it that way, then whether it's a x cubed plus 8 or a minus 8, it's not going to matter. You'll get the correct factoring either way. So let's try another one. We have w cubed minus 27. So the cube root of 27, or what I cubed to get 27, is 3. So if I think about factoring this, I'm going to write out my binomial and my trinomial here. In my binomial, I'll just have whatever was being cubed, which is just w and 3. Then I am going to square w to get my first term in my trinomial, and 3 to get my last term in my trinomial. And then my middle term comes from multiplying w and 3 together, so 3w. And then my signs are the same, so it was minus, and then opposite, and then always a plus for my last one. Now I'm just going to rewrite it with things simplified a little bit. You'll have w minus 3 times w squared plus 3w plus 9. And that trinomial will not factor further. You don't have to try guess and checking or anything like that. It's going to be prime. On this one, I'm going to let you do it once I get you started. So if you don't know what you cube to get 27x cubed and 125, you can always do the third root, break it down, or use your calculator. You'll get 3x and 5, and then see if you can fill in what this would factor to give you. Let's look at one more. So it doesn't look immediately like cubes or squares, but factor out that common factor. I'm going to factor out a negative 2d squared. You could do a positive 2d squared. I'll do that in a second, but I'm going to pull out the negative, which would leave me with d cubed minus 125. And then if you think about your cube roots, what you cubed to get 125 is 5. What you cubed to get d to the third is just d. And then you'll have d squared, 5 squared with your middle term of 5 times d. Signs are same minus as I had, opposite as a plus, and then an always a plus. And then I'm just going to rewrite it with my 5 squared is 25 basically, and that will be my factored version. You could multiply it all back together and check if you wanted to. I'm going to show you another option, which just for you to know that it's not wrong if you just factor out a positive 2d squared. That would leave you with a negative d cubed plus 125. And then I would probably reorder it and make it 125 minus d to the third. You could make that into, if you think about still, what do you cube to get 125? What do you cube to get d? 5 and d. Things are going to be in a little bit different order, but this is also totally fine and would still equal your original expression.